precision handling ensures that no human contaminants touch the fibers, as the robotic filament window. Automated precision handling ensures that no precision ground steel fiber serves as the robotic filament window. Automated precision handling ensures that no precision ground steel fiber serves as the robotic filament window. Automated precision handling ensures that no precision ground steel fiber serves as the robotic filament window. Automated precision handling ensures that no precision ground steel fiber serves as the robotic filament window. Automated precision handling ensures that no precision ground steel fiber serves as the robotic filament window. Automated precision handling ensures that no precision ground steel fiber serves as the robotic filament window. Automated precision handling ensures that no precision ground steel fiber serves as the robotic filament window. Automated precision handling ensures that no precision ground steel fiber serves as the robotic filament window. Automated precision handling ensures that no precision ground steel fiber serves as the robotic filament window. Automated precision handling ensures that no precision ground steel fiber serves as the robotic filament window. Automated precision handling ensures that no precision ground steel fiber. Layer by layer, the yoke goes up middle and automated precision designed to begin with no precision ground steel fiber. Layer by layer, the yoke goes up middle and automated precision designed to begin with no precision ground steel fiber. Layer by layer, the yoke goes up middle and automated precision designed to begin with no precision ground steel fiber. Layer by layer, the yoke goes up middle and automated the assembly is beginning with a special precision. Layer by layer, the yoke goes up middle and automated the assembly is beginning with a special precision. The fuselage and layer by layer, the yoke goes up middle and automated the assembly is beginning with a special precision. The fuselage and layer by layer, the yoke goes up middle and automated the assembly is beginning with a special precision. The fuselage and layer by layer, the yoke goes up middle and automated the assembly is beginning with a special precision. The fuselage and layer by layer, the yoke goes up middle and automated the assembly is beginning with a special precision. The fuselage and layer by layer, the yoke goes up middle and automated the assembly is beginning with a special precision. The fuselage and layer by layer, the yoke goes up middle and automated the assembly is beginning with a special precision. The fuselage and layer by layer, the yoke goes up middle and automated the assembly is beginning with a Internal temperature sensors monitor the exothermic reaction, ensuring a uniform cure throughout the grain's volume. The resulting star grain geometry provides a massive surface area for instantaneous thrust upon ignition. Controlled cooling stabilizes the solid propellant, preventing thermal cracking during the transition to ambient temperatures. The dual-pulse heart of the Patriot is now ready a powerhouse, capable of hypersonic interception. The nose cone, crafted from advanced ceramics, is prepared to house the most sophisticated radar seeker in the world. The signal processor, the brain of the seeker, is integrated into the core chassis of the ocular unit. Force radar with its center. Power-armed sensor. Sweep's ability to measure. Tested now can hit. The heart of the sea, tungsten for transfer. Precision laser, the perfectly frame. Heavy-duty mechanical locks secure the core to prevent any shift during Mach 5 maneuvers. This ring houses hundreds of titanium fragments designed to deploy if a direct hit is not achieved. Automated high-torque systems prepare to seal the warhead assembly into the primary structure. Electronic firing circuits are linked, connecting the warhead's lethality enhancer to the flight computer. Onboard diagnostics confirm the kinetic core is live and fully integrated into the missile's logic. A protective composite shroud is applied, shielding the lethal core from aerodynamic heating. With the tungsten lethality core secured, the PAC-3MSE is one step closer to its final mission. Every movement is controlled to sub-millimeter precision to ensure perfect alignment with the launch guide rails. The modular canister is the primary housing designed for rapid replacement in the field. As the missile seats, the rear interface aligns with the battery data link umbilical. The handshake between the interceptor and its housing is complete. The OC-3MSE's modular design allows for 16 missiles to be carried by a single trailer. Physical security is paramount to ensure stability during the violent forces of a launch. The NTDO OC-3M fully integrated, standing ready to defend the theater from ballistic threats. Radar searches for anomalies in the upper atmosphere, seeking the signature hostile threat. The target initiation and verification protocols. Transitioning from search to track, the radar concentrates its energy into a narrow high-power beam for precision lock-on. Data is shared across the theater missile defense, ensuring synchronized engagement with THAAD and Aegis assets. The fire command is sent. The countdown to intercept begins. The irrevocable. Ignition achieved. The interceptor breaks its seal, beginning its hypersonic journey to the target. Pressure builds instantaneously as the dual-pulse rocket motor's first stage ignites within the launch tube. The guidance system initiates the pitch-over maneuver, aligning the interceptor with the projected intercept point. Structural integrity is tested as the airframe endures massive longitudinal G-loads. Breaking the P generates sonic supersonic regime. Advancing to Mach 3, the ceramic and titanium components dissipate extreme thermal energy. Entering the hypersonic regime, the air itself begins to ionize around the hardened seeker window. Precision pyrotechnic charges sever the structural reduced to its most agile form, the interceptor at hypersonic velocity, ready to engage the incoming threat. Ring consists of 80 tiny soliders, designated. For input motors fire. Like traditional AC pure lap shifting gravity, this enables the interceptor to perform a 30 Gs. The flight is no longer a curve, but a series of vectors. Control is simultaneous, ensuring remains fixed. The attitude control form the final height to align the interceptor for control system provides agility at hypersonic speeds. Concludes kinetic destruction. The K-band active radar seeker provides precise telemetry guiding the interceptor toward a direct collision path with the incoming threat. Impact. The hit to kill technology, pure velocity force breaching the target's property. Simultaneously, the lethality enhancer deploys, casting a dense cloud of titanium fragments to ensure total neutralization of any submunitions. Atmospheric shockwave marks the point of interception, signaling the complete ballistic threat. Kill assessment data is confirming the total neutralization of the incoming tactical ballistic missile. With the mission accomplished, the launching station prepares for relocation. Modular canisters ready for rapid reloading. From fabrication to kinetic vaporization, Scepter represents the pinnacle of modern aerospace engineering and defense. Precision and power strength steel is for red-hot steel transforms into robust armor plates forged with precision. The journey begins as essential material factory for production. Precision leads the journey of the EV's robust chassis components. Skilled technicians meticulously oversee the automated process. Cut is perfect. From raw steel to factory floor hums with efficient, advanced manufacturing. Skilled American welders begin constructing the Oshkosh L with unmatched precision. Through concentrated effort, every joint is strengthened, forming the foundation of unparalleled durability. Each rigorous inspection ensuring structural integrity for extreme conditions. Every detail is handled with care, from foundational welds to final structural reinforcement. The strength of every guarantees resilience forged by dedicated craft. engineering begins fabrication component. Skill integrate robust shock unmatched quality. Are expert learning seamless. Every bolt exact guaranteeing structure. Take 4 item is now resting.
All tolerant.
Precision and street chassis inspected.
This junction tolerance, the spot on.
Let's mount torque.
Every ATV moves those who serve. The journey of the Oshkosh begins with its high-performance tool engine. Teams of highly carefully for its crucial journey to the assembly line.
Sequence initial ATV powertrain installation. All teams stand by.
With utmost care, the engine is precisely positioned over the waiting chassis, ready for integration. Skilled technicians meticulously guide the powerful engine into the LATV chassis.
A little more to the left.
Got it. Looks aligned.
Every connection in the LATV's reliability and performance. The electrical systems are integrated, bringing the LAT life. Tightened to occasions, guaranteeing structural integrity. Is meticulous for quality ability. And ensures complex systems.
Torque wrench now. Hold it steady, securing the fastener.
Line connector inspections. Confidence in there is the LATV's readiness for skilled artistly weld the it's forming the LATV's protective hull. Design is engineered for against battlefield. Each weld rigorous and unmatched structural integrity and safety. The capsule armored cabin is built for unparalleled crew protection. Every component is designed for optimal performance and battlefield readiness. From raw materials to a resilient finished product, every detail ensures reliability. Precision is paramount, as advanced armor components are meticulously integrated. Each window installation guarantees unwavering protection and structural integrity. The heavy, blast-proof doors represent another critical layer of defense. Every detail from the seal to the lock reinforces the vehicle's impenetrable defense. Precision engineering unites form and function, bringing the armored capsule to its rugged chassis.
Tapping confirms the seal is secure.
Suspension test sequence initiated. Values are stable. Looks good.
With utmost precision, the armored capsule descends poised for its union with the chassis below. The capsule settles into place, forming the formidable core of the LATV's protective structure. Each bolt ensures unmatched strength and protection, forging an impenetrable combat vehicle.
That's a wrap on the new LATV. Flawless integration. Well done, team.
Inside the armored cabin, the expert meticulously inspects every weld and seal for uncompromised integrity. Precision engineering ensures these run-flat tires can endure the harshest conditions. Skilled hands work with specialized tools, ensuring every component is perfectly aligned. Each completed wheel assembly stands ready for integration onto the Oshkosh LATV. Expert technicians meticulously connect the vital CTIS pneumatic lines, ensuring flawless performance for demanding terrains.
I've got the cable routed through the frame.
Okay, I'm securing the clamp now. Looks good.
Every connection is meticulously secured, guaranteeing the CTIS operates flawlessly under extreme conditions. Each CTIS connection undergoes rigorous pressure testing, ensuring maximum durability and reliability. Precision engineering ensures every wheel unit is perfectly aligned for attachment. Each lug nut is carefully started by hand, ensuring correct threading before pneumatic tightening. Final torquing confirms the wheel is securely fastened for the most demanding conditions. Precision is paramount as the advanced weapon station is carefully hoisted into position.
Easy now, just a fraction to the left. Looks aligned, set it down. Clear.
Skilled
good.
hands ensure perfect alignment, a crucial step
Confirmed
for mission
alignment.
readiness. Integrating critical electronics for seamless battlefield networking and control.
Full functionality.
Precision wiring ensures seamless battlefield communication. Every screen is integrated for optimal crew awareness. Complex networks are expertly crafted for mission success.
Tracing the blue lead now. Connection verified.
Advanced systems are installed with utmost care.
Radio check, testing voice transmission. How copy? Over.
Rigorous testing ensures the LATV's unparalleled protection. Witness advanced engineering withstand extreme forces. Every detail is scrutinized for peak performance. Grueling deep-water fording tests validate the LATV's unparalleled amphibious capabilities. Engineered for extreme environments, it navigates the course with unwavering stability. This rigorous testing ensures absolute chassis durability and operational readiness. On the brutal Belgium, LATV's advanced suspension faces its ultimate test. Watch as the S-frame twisting remaining intact and stable. The suspension system ensuring control. To deep ruts, the L's crew protection and through LATV proves its unparalleled durability and off-road supremacy. Ultimately, the OSV stands ready for any mission and completed LATVs stand ready at test engineering. Ready testament to American ingenuity and strength. The journey 6 Pershing deep within the to forge a tank steel shaped for unparalleled. Giant rollers fill into the M Pershing's fates. Arrive the Pershing product. Craftsmen prepare HAM Pershings for plasma torches ignite, poised to carve the future armor of the M26 Pershing from raw steel. Each precise cut shapes the critical slope glosses, ensuring maximum protection for the M26. From sides to each M26 hull component is crafted with unwavering accuracy.
This section is clear. Are you ready with the main welder?
Yes, just finalizing the calibration now.
Skilled welders fuse massive steel plates, forging the M26 Pershings in hull. Precision and teamwork define this critical stage, ensuring superior structural integrity. Each meticulous, seamless bond, vital for combat resilience.
Watch the clearance on Bay 4.
Looks clear. Keep it moving slow.
Molten steel, glowing intensely, prepares for its transformative pour. Thousands of pounds of molten steel now 426 Pershing.
Keep the flow steady, we're almost at the riser.
Confirmed. Watching the temperature spike.
Massive machines meticulously mill the cooled turret, shaping the M26's formidable protection. Precision engineering ensures the turret ring race is perfectly accurate for seamless operation. Skilled machinists guide the powerful tools, openings for the tank's main armament.
72.005.
Confirmed. That's within tolerance.
Machinist begins shaping the Ford GAF V8 engine block, automated machinery. Each engine block undergoes milling to achieve tolerances critical for performance. Each cylinder bore is carefully measured to guarantee it meets the M26 Pershing's exact specifications. After machining, each engine block receives a final, thorough quality inspection by expert hands. Precision begins as V8 engine blocks arrive, awaiting expert assembly for the M26 Pershing. Piston rings are expertly fitted, a delicate task ensuring optimal engine performance in seal. The heart of the engine, the crankshaft, is meticulously lowered into its designated position. Valve train intricate and numerous, prepared for their crucial role in engine timing. Cylinder heads are gently lowered, sealing the block and completing the engine's combustion chambers. Steel bars are forged, transforming raw material into the backbone of the tank's suspension. Skilled American workers meticulously monitor each bar, ensuring unparalleled strength and durability. The completed torsion bars undergo rigorous inspection, ready to equip the M26 Pershing. Skilled American hands begin the critical task of assembling the Pershing's robust suspension. Each component is secured with unwavering attention to detail, vital for battlefield performance. Torsion bars, the tank's backbone, are carefully integrated into the hull for essential shock absorption. Molten steel, forged by immense pressure, begins its transformation. Skilled operators guide the powerful press, meticulously shaping the future cannon.
The temperature on the billet is holding steady at 1200. Good. Maintain pressure for another 2 minutes.
Each impact refines the formidable 90mm barrel, crucial for Pershing's power. Inside the gun rifling shop, precision machining begins on the M26 Pershing tank barrels. The specialized cutting head is carefully advanced into the barrel, ready to begin its critical task. Coolant flushes away metal fragments, ensuring a pristine and precise cut. The barrel rotates with micro-precision, aligning for the next perfectly spaced groove. After countless passes, a specialist performs the final, meticulous inspection of the completed rifling. Skilled American machinists meticulously transform raw steel into vital M26 Pershing breech components. Each surface is ground to a flawless finish, ensuring optimal performance and durability. Every dimension is rigorously checked, guaranteeing unwavering reliability for the M26 Pershing. With final inspection complete, another precision component is ready for assembly. Skilled hands begin assembling the complex M26 Pershing breech, piece by precise piece. Each intricate component is meticulously fitted, ensuring flawless operation of the firing mechanism. The powerful breech block undergoes rigorous manual tests, its action smooth and reliable. Skilled hands prepare the powerful Ford GAF V8 engine for its crucial journey into the Pershing. With precision, the powerful engine assembly begins its course across the main assembly line.
Hold your positions, it's almost here.
Looks like a tight fit.
American ingenuity guides the heart of the Pershing tank into its destined place with meticulous care. The M26 Pershing's power pack is now integrated, a testament to precision manufacturing. The formidable M26 Pershing turret, gun installed, awaits its union with the hull.
We need to check the tolerance right here.
Already done the cleaning pass. Tolerances are within spec.
A colossal crane lifts the turret, a precise maneuver requiring skilled hands guide the massive turret, ensuring perfect alignment with the waiting hull.
The turret alignment is showing a deviation of less than 0.01.
Confirmed. The centerline variance is within tolerance.
With precision, the components lock into place, forming the formidable M26 Pershing. Meticulous assembly ensures every Pershing tank meets the highest standards of readiness. Each component, from optics to armament, undergoes rigorous installation for peak performance. Inside, thousands of internal wires and hydraulic lines converge, a testament to complex engineering.
Check the alignment on the drive sprocket.
Looks good from here. Bring this hatch down.
Skilled American workers meticulously connect each M26 Pershing tank track link, forming the tank's.
Bring it down slowly now, watch the alignment. Clear on the left side, a little more to the right. All right, set her down easy.
Teams work in unison, guiding massive M26 Pershing tracks around the tank's robust road wheels and drive sprocket. Precision and strength combine as workers ensure every M26 Pershing track link is securely fastened. The M26 Pershing's imposing tracks take shape, ready for the battlefield. With the tracks in place, the M26 Pershing is nearly complete, a testament to American manufacturing. The M26 Pershing, a symbol of American ingenuity, now moves under its own power. At the proving grounds, the M26 Pershing demonstrates its unparalleled mobility, conquering formidable terrain. Its advanced torsion bar suspension absorbs the shocks, providing stability and crew comfort. At the proving grounds, the M26 Pershing readies for live fire testing.
Acquiring target now.
Shell, up, locked, and ready.
Precision engineering ensures rapid reloading and sustained firepower. The M26 Pershings, formidable and ready, depart the factory for their vital mission. These formidable machines, born from meticulous production, now stand ready for any challenge. From raw earth, the foundational elements for the M551 Sheridan begin their journey. Raw bauxite ore begins its transformation, meticulously processed for critical tank components. Across vast American landscapes, vital raw materials journey towards the M551 Sheridan tank factory. From raw materials, precision begins, forging the essential components for the M551 Sheridan tank. Skilled hands and advanced technology work in concert to ensure the highest quality standards are met. From fiery depths, pure molten aluminum flows, ready to be shaped into crucial tank components. This fundamental step ensures the production of lightweight, durable aluminum crucial for military-grade vehicles. Molten 7075 aluminum alloy, crucial for the Sheridan tank strength, is prepared for casting. After casting, these substantial billets cool, forming the foundational blocks for the tank's hull. The immense 7,075 aluminum billet enters the hot rolling mill, beginning its transformation into skilled American workers meticulously monitor the rolling process, ensuring precision for every tank hull plate. These robust 7,075 aluminum plates cool on conveyors before being precisely stacked.
Manifest confirms grade A, 7175 plates. All 20 bundles accounted for.
Precision begins as raw aluminum transforms into vital components For the M551, Sheridan's rope intense plasma jets precisely slice through metal, shaping the tank's defensive armor with controlled power. Skilled American craftsmen meticulously inspect each part, ensuring every dimension meets exact M. These precisely cut components are now ready for the next crucial stage. The M551 Sheridan's expert assembly. Massive aluminum hull plates are precisely positioned, forming the foundation of the M551 Sheridan. The arc ignites, sparks fly, as skilled hands begin joining the vital aluminum sections. Coordinated teams work in unison, meticulously crafting the tank's robust aluminum shell. Multiple welding stations hum with activity, assembling the formidable Sheridan hull section by section. Behind the glare, American welders demonstrate unparalleled focus, forging the strength of each tank.
The tolerances on this weld are exceptional, exactly to spec.
Agreed, the craftsmanship is flawless.
Precision machining begins, shaping raw steel into the iconic M551 turret. The main gun mount takes shape. Sheridan's powerful coolant reveals the flawless finish of meticulously sculpted steel. The M551 turret, transformed by advanced machinery and skilled hands, nears completion. Precision engineering brings these complex systems to life. Vital lubrication ensures smooth, reliable operation under any conditions. Each component is meticulously secured, guaranteeing unwavering structural integrity. Careful integration merges components into a formidable weapon system.
Keep the pressure even.
It's gripping. One more turn should.
The formidable 52mm gun barrel is prepped within the 50. The massive 100mm gun barrel is carefully hoisted, ready for precise turrets.
Easy. More to the left.
Specialized tools are ensuring every component of the gun's mounting is aligned. Meticulously verify every dimension and angle, ensuring the gun's precision is flawless.
A little more.
Okay.
Every movement of the M551 Sheridan's gun is tested, guaranteeing battle. Primary weapon in the M551 Sheridan's ready for further. Precision begins on the engine assembly line, where advanced robotics initiate the component preparation is meticulous, ensuring exact specification. Pistons are expertly seated within the engine cylinders, a critical step for performance. The heavy crankshaft is precisely positioned, forming the engine's rotating core. Human expertise ensures every critical bolt is torqued to exact specifications. Another expert ensures all fasteners are perfectly secured for optimal engine performance. The completed engine block moves forward, ready for the next stages of assembly. Precision engineering begins with each torsion bar, crucial for the Sheridan's agile suspension. Each torsion bar is precisely integrated, forming the backbone of the Sheridan's innovative suspension.
Easy now. Lower it slowly. Make sure the alignment pins match.
Looks good from here. Go ahead and clamp it down.
Large road wheels for the M551 Sheridan arrive, ready for precise integration. Expert hands carefully position each large road wheel onto its designated suspension arm. Securing the road wheels is a meticulous process, critical for the M551's battlefield reliability. Completed M551 suspension units are now ready for seamless integration into the tank's aluminum hull.
Final check on this unit. Make sure the specs match the tablet.
Everything aligns perfectly. Move it to QA.
Check the schematics for the turret ring alignment.
Already on it, verifying tolerances now.
The M551 Sheridan hull is prepared for its journey to the main assembly line. With practiced ease, the hull is precisely lowered onto its designated position. Precision begins as the powerful Detroit diesel heart is readied for installation. Skilled hands guide the robust engine, ensuring perfect placement within the tank's chassis.
Easy now, watch the clearance on the left side. Got it.
Just a hair lower.
Clear on down.
The crucial drive shaft is joined, connecting power to the tank's formidable mobility.
Solid.
With meticulous care, the power pack is fully integrated, a vital step in the tank's combat readiness. Skilled American workers guide the heavy turret with precision tool. The M551 turret gently settles into its designated position on the hull.
Check the alignment on this panel right here. Looks solid, ready for sign off.
The newly unified M551 Sheridan stands, a testament to precision engineering. Skilled hands bring the tank's operational systems to life, piece by intricate piece. Every connection is vital, forming the tank's robust and responsive nervous system. From power to targeting, each circuit adds to the Sheridan's formidable capabilities. Advanced diagnostics begin, ensuring every system on the M551 Sheridan is perfectly tuned. Commands are loaded, activating the shared internal systems. Data streams activate, displaying real-time insights into the tank's operational health. Real-time diagnostics confirm the turret's precise motor performance and alignment. Detailed telemetry verifies the gun's elevation system, ensuring pinpoint accuracy.
Let's review the calibration data.
See this critical reading on the hydraulics. It's unstable.
Agreed. I'll adjust the servo valve gain as per the schematic.
All M551 Sheridan systems are verified, ready for the next stage of production. In the factory testing bay, the heart of the M551 Sheridan prepares for its debut. The mighty Detroit diesel engine ignites, filling the bay with its raw power. Workers meticulously monitor banks of gauges, seeking operational perfection. Trained ears detect the slightest anomaly in the engine's powerful song.
We need to adjust the fuel injection timing based on these readings.
Agreed. The pressure spike at 2,000 RPM is still too high.
Skilled hands perform fine adjustments, perfecting the engine's performance.
As you can see, the temperature, RPM, and pressure are all running optimally.
Looks good. We are ready for the next phase of testing.
With all checks complete, the engine runs flawlessly, a testament to American engineering. On the proving grounds, the Sheridan's agility and power are rigorously put to the test. The M551 Sheridan, a nimble, light tank, proving its worth on the battlefields of Vietnam. Its rapid deployment and powerful armament made it a crucial asset for American forces. The birth of a Merkava Mark IV begins in the white heat of the blast furnace, where ballistic steel is refined to a perfect liquid state. The molten metal is channeled into a single-piece mold designed to create the Merkava's signature monolithic lower hull. This casting process eliminates structural weak points, providing a foundation that can withstand the most extreme kinetic impacts. Special attention is paid to the forward compartment, uniquely designed to house the engine as a secondary layer of crew protection. Every channel and cavity within the mold is precision engineered to ensure uniform thickness across the entire ballistic structure. Complex internal geometries are formed using specialized cores, allowing for the integration of the tank's hydropneumatic systems. Once the mold reaches capacity, the liquid steel undergoes a settling process to remove any microscopic air pockets. Impurities are meticulously removed, leaving only the highest grade high-strength steel for the final hull. Controlled cooling begins. This phase is critical to achieving the specific crystalline structure required for ballistic resilience. As the temperature drops, the steel undergoes a molecular transformation, hardening into a formidable armored shell. The molten genesis is complete. The liquid fire has become the unyielding bone of the Merkava. The manufacturing floor prepares for the extraction of the massive casting weighing dozens of tons. For the first time, the iconic shape of the Mark IV hull emerges from its subterranean birthplace. The temporary casting supports are discarded, revealing the precision cast engine bay and crew compartment. Initial finishing begins immediately, removing excess material from the casting process while the steel is still malleable. Precision cleaning of the internal steel pockets ensures a perfect molecular band for the upcoming inserts. Alignment is verified to within microns, ensuring maximum kinetic energy dissipation across the armor surface. Modular steel plating is layered over the ceramic core, creating the first stage of the multi-layered defense. The high-pressure hydraulic forge activates, exerting hundreds of tons of force to laminate the layers. Thermal bonding fuses the ceramic and steel components into a single indestructible composite unit. Post-bonding inspection reveals a perfect molecular interface essential for structural integrity. Reinforcement proceeds to the critical side skirt zones where modular armor provides vital flanking protection. A secondary alloy mesh is integrated into the side modules to provide multi-hit capability against shaped charges. Precision laser welding seals the outer shell, encasing the composite materials in a steel cocoon. Rapid cryogenic cooling stabilizes the crystalline structure of the armor, preventing stress fractures. Non-destructive X-ray testing but confirms the absence of internal voids or delamination in the composite core. Surfaces are ground to sub-millimeter tolerances to ensure the modular armor blocks fit perfectly. The frontal glacis receives its final high-density compression, completing the tank's most impenetrable section. With the ceramic core successfully infused, the Merkava's hull is now a formidable fortress ready for engine integration. Preparation begins in the forward compartment, where every surface is treated to withstand extreme mechanical stress. Precision alignment is critical. The engine's position is measured to within fractions of a millimeter. This forward engine configuration is a unique design choice, prioritizing crew survivability above all else. High torque fasteners secure the powerhouse, ensuring it remains a stable shield even under intense fire. Reinforced fuel lines are connected, designed to remain intact during the violent vibrations of cross-country movement. Advanced cooling systems are installed to manage the immense heat generated by 1,500 horsepower. Desert-ready air filtration ensures the V-12 breathes clean air even in the thick of a dust storm. The exhaust is routed specifically to minimize the tank's thermal signature from the front. A secondary armored bulkhead is installed, providing a final layer of protection for the tank's occupants. Structural integrity is reinforced, fusing the engine's housing into the very skeleton of the hull. The transmission is primed, ready to translate raw torque into battlefield mobility. A final digital sweep confirms that every component is perfectly seated within the chassis. The forward heart beats for the first time, proving the machine's power and reliability. With the engine secured, the Merkava Mark IV now possesses its most defining characteristic, a shield of steel and power. The integration of the main armament begins with the precision lubrication of the turret ring assembly. The MG253 smoothbore gun, a masterpiece of ballistic engineering, is positioned for mounting. Engineers oversee the insertion of the breech block designed to withstand extreme chamber pressures. The precision crane lowers the entire artillery assembly into the reinforced turret cradle. The dual recoil buffers are installed to absorb the immense energy of the 120mm discharge. The barrel is perfectly aligned with the turret mantlet using high-precision laser telemetry. Forged steel trunnion pins are seated, creating the pivot point for vertical elevation. The elevation actuators are engaged, linking the gun to the computerized fire control system. The bore evacuator is fitted to prevent toxic propellant gases from entering the crew compartment. Initial elevation tests verify the mechanical range of motion for the smoothbore system. Depression limits are tested, crucial for the Merkava's hull-down combat tactics. Optical and laser range-finding sensors are aligned with the gun's primary axis. The turret is permanently mated to the hull, securing the smoothbore fist to the chassis. Fiber optic data lines are connected, providing the high-speed throughput required for millisecond threat detection. The first of 4 Elta radar antennas is seated, forming the eyes of the tank's defensive perimeter. Symmetry is vital. The second radar unit is installed to provide full frontal hemispherical coverage. Laser-guided alignment ensures there are no blind spots in the radar's 360-degree field of view. With the 4th panel in place, the trophy system achieves total situational awareness around the hull. The central processing unit, the brain of the active shield, is housed deep within the turret for maximum protection. The interceptor magazines containing the hard kill countermeasures are prepared for docking. The magazines lock into the launchers, establishing a physical link to the fire control system. Servo motor calibration begins, ensuring the launchers can track incoming missiles at supersonic speeds. Dual launchers provide redundant protection, allowing the Merkava to engage multiple threats simultaneously. Main power is routed from the tank's V12 engine generators to the high-draw APS capacitors. System handshake complete. The software synchronizes the radar data with the interceptor firing solution. The trophy integration is finished, transforming the Merkava Mark IV into an impenetrable armored fortress. The transformation into a network powerhouse begins with the installation of high-speed fiber optic data buses. These cables form the backbone of the Digital Army Battle Management System, allowing instantaneous data transfer. The main processing core is secured within a hardened, shock-resistant housing to survive the rigors of the battlefield. Thermal management is critical for maintaining peak electronic performance during prolonged, high-intensity operations. The crew interfaces are mounted, providing the gunner with a comprehensive digital tactical picture. The commander station is integrated, merging sensor feeds into a unified command and control interface. External communication arrays are linked, connecting the Merkava to the wider Digital Army network. External situational awareness cameras are synced, eliminating blind spots for the driver. System diagnostics verify the integrity of the networked architecture across all crew stations. Transitioning to the rear, the unique clamshell door system begins its mechanical integration. High-pressure hydraulic pistons are installed to facilitate the rapid opening and closing of the rear access. The lower ramp is fitted, creating the unique exit path for crew evacuation or infantry support. Industrial-grade seals are applied to ensure the rear compartment remains NBC protected and watertight. Digital sensors are integrated to alert the crew of the door's status via the battle management system. Reinforced locking lugs engage, securing the rear portal against external kinetic threats. The digital nervous system is now fully online, transforming a mechanical titan into a network predator. Before the skin is applied, ionized air purifies the ballistic steel of every microscopic impurity. A zinc-rich primer creates the essential bond between the steel and its future thermal defenses. Rapid UV curing ensures the base layer is chemically locked, preparing for the infrared reflective coating. The infrared reflective base coat is applied, designed to scatter thermal energy and minimize the tank's heat signature. Atomized pigments are layered with precision, creating a surface that mimics the spectral properties of desert sand. Critical sensors are protected as the final protective layers are prepared for application. Non-linear patterns are introduced to break up the tank's silhouette against the shifting dunes of the Negev. An anti-slip texture infused with ceramic beads is applied to the top surfaces, ensuring crew safety during high-speed maneuvers. Validation begins. The IRR coating is tested to ensure it masks the internal heat of the machine from enemy sensors. On the factory floor, the 600mm heavy-duty tracks are laid out ready to support the 65-ton Fortress. The drive sprocket engages, beginning the process of wrapping the tank in its massive steel shoes. A hydraulic winch pulls the multi-ton track over the return rollers with calculated force. The track tensioning system activates, extending the idler wheel to achieve the perfect balance of flexibility and grip. The hydropneumatic suspension adjusts instantly, compensating for the weight of the new steel tread. Every bolt is torqued to precise specifications, ensuring the tracks can withstand extreme cross-country stress. The first rotation, the 600mm tracks move with a rhythmic power that signals the tank is ready to crawl. The Merkava Mark IV stands complete, a desert-colored Predator, armored, tracked, and ready for deployment. Validation begins in the crucible of the Negev, where the terrain provides the first true test of the Merkava's structural integrity. Vertical obstacle clearance and steeping confirm the torque efficiency of the GD 883 power pack. Agility testing ensures the tank can maneuver within the confined, treacherous spaces of a mountain pass. The 600mm wide tracks are evaluated for ground pressure distribution and link durability. Engineers monitor the low ground pressure profile, essential for maintaining mobility in shifting dunes. The structural wells of the front-mounted engine compartment are stressed to simulate the violence of modern combat traversal. A simulated incoming threat is launched to validate the system's detection to intercept latency. The battle management system identifies the threat trajectory in milliseconds, calculating the optimal intercept point. The high-precision launcher slews into position, slaved to the radar's tracking data. The Mail Ruach interceptor is deployed using a matrix of small projectiles to neutralize the threat at a safe distance. The interception is successful. The incoming missile is destroyed before it can contact the modular armor skin. Post-intercept, the vehicle maneuvers through the kill zone, its thermal signature suppressed by infrared reflective paint. Proving ground sensors log the data confirming the trophy system's 100% interception rate. Physical and electronic trials complete the individual unit transitions from a factory machine to a combat-certified asset. The trial by fire is over. The Merkava Mark IV is now ready for deployment to the front lines. The heart of the digital fortress awakens as the battle management system initializes its high-speed processing core. Integrated Delta radar sensors begin filtering environmental data. Identifying potential threats through solid urban obstructions. The advanced fire control computer isolates the target, calculating variables and distance in milliseconds. Precision operator to manipulate the massive turret of a surgeon's scalpel. Moving into a hull-down position, the tank minimizes its reinforced turret exposed to the urban corridor. A precision laser range for the exact distance to the target directly into the ballistic computer. The trophy. This interface enters a protective hemispherical shield around the system compensates for target velocity, a first-rate regard. Spectrals through smoke cover combatant signature. Stabilize main arc's movement. Rock steady. Time data tank to drones. Odds eye vision and murder prepare engagement. Positioners every rooftop tunnel in the transition to is complete. The Predator is now the master of the urban. Technicians monitor pressure fluctuations and still handle the extra cross-country maneuvers. The heavy-duty tracks undergo tension testing, compensating for the wear and tear of terrain. Ultra scanners seeing microlistics that are invisible to mortars with organic and abilities. Damaged armor modules are swapped in minutes, a testament to the Merkava's design for rapid battlefield sustainment. The Digital Army re-establishes high-bandwidth links with overhead Heron drones for real-time intelligence. With the rear access doors sealed, the crew compartment is fully protected against CBRN threats and kinetic impact. The control system undergoes a final self-calibrating the thermal with the 100 bore gun. The red is in the tank remains a ghost on the thermal sensors of the enemy. Deployment begins. The Merkava takes its position as the tip of the spear in a coordinated multi-domain assault. Built for survivability, engineered for dominance, it stands as the ultimate synthesis of armor, firepower, and intelligence.